what you can do, if we need to actually talk about enumerating outcomes of an experiment like this, a very easy way to do it, because Faith, you're correct, there are 3 outcomes, but there's 3 outcomes for you and 3 for me, is you can use a tree diagram. And the project explains these in great detail, but I'll just give you an introduction to them. So you start, and let's make it sequential, even though it does happen at the same time. You throw something, and I throw something, right? So you throw, and I throw. Right? You throw something, and then I throw something. I'm going to make it sequential, but it actually happens simultaneously. What could you throw? Rock, paper, scissors, right? Rock, paper, scissors. Yeah? Make sense? What can I throw?
Same thing.
The same thing for each of the 3 that you throw. So if you threw rock, I might have also thrown rock, or paper, or scissors, yes? But if you threw paper, I would have also maybe thrown rock, or paper, or scissors. And if you threw scissors, I may have thrown rock, or paper, or scissors. Now, if you follow any of the branches of that tree, you'll see one of the possible outcomes of the experiment that we just witnessed. We witnessed all of these as we went through that little game. Let's check them all out. Here are the outcomes. Rock, rock. That means you threw rock and I threw rock. Rock, paper. That means you threw rock, I threw paper. I'm making it an ordered pair, if that's okay with you guys. I'm not to piss you off, but just to keep the whole idea of XY coordinate. If it's RS, you threw rock, I threw scissors. Good so far?
Yeah.
PR is different than RP, isn't it?
Yeah.
PR means you threw paper, I threw rock. RP means you threw rock, I threw paper. Fair? PP, we both threw paper. PS, you threw paper, I threw scissors. SR, you threw scissors, I threw rock. SP, you threw scissors, I threw paper. SS, we both threw scissors. How many different possible outcomes are there for rock, paper, scissors? 9. There are 9 possible outcomes in rock, paper, scissors when you play against somebody. Because you can throw 3 and they can throw 3, and there's a neat little rule you just learned called the multiplication rule. We'll study it in 243 in great detail. But there are 9 outcomes. Here's what I want to know right now. In how many of those do you move on to the next round when you're playing it in our way right here, correct? So let's suppose we both threw rock. You threw rock and I threw rock. Did you keep going in the next round there? You did, because I didn't beat you, correct? The only time you stopped is if I beat you. If we tied, which is what that is, if we tied, you keep going, correct? How about if you threw rock and I threw paper? You threw rock, I threw paper, doesn't that mean I win? Paper covers rock. That one doesn't go on. Fair? How about you threw rock, I threw scissors? You keep going, because you beat me there. So what you see is, this is a tie, this is a loss, this is a win. That's going to happen in each of these. Because any of the ties, paper, paper, scissors, scissors, you go on. Because you didn't lose to me. The only way you're not going to go on is if you lose to me. How about paper? You threw paper, I threw rock.
You go on.
You go on because you beat me, didn't you? If you threw paper and I threw rock, you keep going. How about you threw paper, I threw scissors?
Out.
You're out because I beat you, right? See a pattern here, friends? Well, not so much a pattern as a repetitive numerical pattern. You threw scissors, I threw rock?
Out.
You're out, I beat you. Rock beat scissors. How about you threw scissors, I threw paper?
No.
You're going. What percentage of the time do you move on? 2/3. About 67% of the time you move on.
So then wouldn't that spot be 33?
No, because it's the maintenance. Thank you for that question, Faith. We dump 33 each time, which means we maintain 67. Thank you for saying that. That's why I call it a maintenance rate. That's why I thought of that, believe it or not, I thought of that word about 3 weeks ago. I've been using this other term called a base. Yes, it's a base. It's basically exponential rod. And if it's less than 1, it's decay. And if it's greater than 1, it's growth. And I realized students were getting freaked out by that. Especially with, these are all called decay models because they're going down. We'll look at growth Wednesday. I realized if I can find one word to stand for both of them, it will confuse them less. At least I hope it will confuse them less. And I realized maintenance. It's the maintenance. You can't call it growth because it's not growing, it's decaying. But you're maintaining 67% on each go. So that's why you stick a 67 here, 0.67, and that models what's actually going to happen. For practice between now and Wednesday, we have 1 minute left. We have less than 1 minute left. We'll finish this question. We'll look at this question. How many rounds on average will it take me to get one person from this room using this model? So in other words, when we start playing the game, there were 29 of you in the room, yes? How many games would I have to play until we got down to one person? Solve that equation, yeah? Solve that equation. See if you can figure it out. We can't do it, well, now we're done because it's new. Namaste. So we'll solve that equation first thing on Wednesday, and then we'll play the game a few times to see if it holds up. Well, because think about it, if you play one game, we're going to lose 1/3 of people. I'm going to make 29/3 to make it easy. So if we play one game, we're going to lose 10 people. We should lose 10 people, which means 20 keep playing. So play another game. We're going to lose 1/3 of them. Are we down to 1 yet? Keep playing until you get down to 1. Or how many games does it take? That's what I'm saying. Does that make sense?
I thought you said how many games would it take just to get a person down.
Oh, no, to get down.